Hi guys, welcome to my channel. My name is Malasa and today I'm gonna be showing you the full complete structural design works of a 20-story building which is going to be constructed here in Addis Ababa, Ethiopia. The project is located in seismic zone 3 and having a spectrum acceleration coefficient of 0.1 g. Hence, the project is located in seismic area. We need to consider the Eurocode 8 and the Ethiopian building code of standard, which has been prepared with reference to the Ethiopian norms during all the phases of our structural design work. So now let me brief you some scope regarding to the architectural design parts of the project. Here, as you see on the screen, this project consists of 20 stories. Among the stories, the 3 stories are below the natural ground level, which are going to be serving for parking, and the rest 17 stories are located above the natural ground level, and which has different offices and service areas. So now let me brief you some scopes regarding to the architectural drawing parts of the project here. This is now let me go to the basement floors, which are gonna be serving for parking. If this is the third basement, here the parking status from here and going up to the second basement, and here this is also the second basement, which has the service area for parking. So and the third one is here. This is the first basement, which is gonna be serving for parking, and here the basement floors are retained with the shear wall at the periphery of the building. Here, when we come to the superstructure, this is the ground floor plan, which has a shear wall here, and here a shear wall here, and we have also a shear wall here. So those 3 shear walls starts at the third basement and ends to the roof of the structures. And when we come to the first floor, here we have a first floor, and here we have also the second floor here and the third floor. Just in similar manner, we have 17 stories above the natural ground level. So when we go to the roof of the project here, here this is the roof plan, and here this is the tanker seats, and here we have also the mechanical floor here, the artist floor here. So when we come to the elevation, this is one of the elevation of the project, and here the second elevation, and here it is also the third elevation, and here this is also the fourth elevations. And when we come to also the sectional view of the design, here all those 3 stories are gonna be serving for parking. Here this is the third basement. It is located at minus 9.6. Now let me zoom it. This one here, it is located at minus 9.6, and this is the second basement floor, which is located at minus 6.4, and here this is the first basement floor, which is located at minus 3.2, and here the ground floor level starts at the level of 0, and it goes up to the uh, the roof stories here. Here, this is the roof level, and the height of the stories is here. The height of the story of the roof is 2.8, and the story height of the mechanical room is 2.88. All the rest of the floors uh, above the ground floors and below the mechanical floors has the height of 3.52, and the story height of the basement floors is 3.2. So, having in mind all this information, so we need to uh, draw the grid system of the project. So, this tutorial will focus on the definition of the grids and grids management regarding to the these 20-story buildings. So now here before just starting drawing the grid system of the project, so we need to draw how many grid lines will be required in x direction and how many grid lines will be required in y direction. So grid lines must be drawn at the center of the structural members as well as at the end edges of the structural members. So now let me uh, show you those grid lines here. When we come to the grid lines which are gonna be drawn in x direction, here we need to have one grid lines along the center line of the retaining wall, and when we come to the second grid lines also, here these grid lines connected the center lines of those columns. So, and the third grid lines will be drawn here. The third grid lines will be drawn here because here we have the center line of the shear wall, and the next grid lines will be drawn here. This one, because here we have a column here, and this grid lines also drawn here because here we have the shear wall here, and this grid lines is drawn also because here we have the shear wall here, and now here we have also the grid lines which connected the center lines of all those columns, and here we have also this grid line because we have a shear wall here, and now here this grid lines is drawn also in order to represent the center line of those columns. And now here we have also these grid lines. This one grid line E because this is the end points of this retaining wall, and here we have also this grid line. So this grid lines connects the center line of this column, and this grid lines is also connected the center line of this column, and this center line is also drawn to connect the center line of this column, and the last one grid is drawn just to connect the center line of these columns. So totally, how many grid lines are there in x direction? So we can count it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here, now let me count again: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 grid lines in x direction, and similarly in y direction we have also the grid lines just to represent the center line of this retaining wall, and here we have also the grid lines to connect the center points of all those columns. And here we have also the grid lines here, because here we have the shear wall, as well as here we have the columns. So to connect the center line of the columns and the shear walls, so we need to use grid line 4. And here we have also the other grid lines. So this grid lines is drawn because here we have a shear wall here, and the other grid lines, that means this grid lines is drawn because here we have a shear wall here. Here at this point here, there is some distance between the ends of this shear wall and the intersection of the grid lines here. When we draw this shear wall, we need to take into account the distance between the intersection of the grids and the ends of the shear walls. So we will see it later during uh, uh, the drawing of the shear wall. So when we come to this one, also here we have a grid lines here, because here we have column here, and here, as well as here. So to connect the center points of those columns, we need to use these grid lines. And here we have also the other grid lines here. So this grid lines is drawn along the center line of this shear wall. And similarly here we have these columns. For the time being, I'm not considering the grid lines here, because later I will draw it manually using draw grid lines. So here I have also the column here. So in order to connect all those columns and this shear wall, I need to use the grid lines too. And when we come to this here, we have the ends of these shear walls around here. So we need to draw the grid lines at ends of the shear wall. So, and the other is here. I have the grid lines here. So this grid lines is drawn because here this is the end of this retaining wall. So the last grid lines along in y direction is this one, because here we have the retaining wall, as well as here we have the columns. So in order to connect the center points of the columns and the center line of the shear wall, we need to use the grid lines here. So during the modeling part, we need to consider the architectural and the aesthetic value of the project. So for this purpose, we need to locate the shear wall and the external faces of the columns at the same lateral levels. So we can use the rigid connectivity here, but later it will create instability problem during the dynamic analysis. So the difference the difference of the locating the center line of the retaining wall here aligned with the center line of the columns, and just providing some centricity is insignificant. So having this in mind, we can consider all the structural members will be concentric to each other. So when we come to the grid management, so I'm going to use etabs 2060 in order to model, analyze, and design this project. So now let me open etabs 2060. So now etabs is taking some time. Okay, here the model initialization dialog box is coming. So I need to use a built-in setting with the metric SI unit. The still section database is it is Eurocode. because I'm gonna be using the Ethiopian building code of standard and the European code of standard. The two codes are similar. So still design code, I can use also the Eurocode 3 2005. If I wanted to use Indian code, just I can select here. If I wanted to use the Canadian code, just I can select here. So just you can select the code that you are going to use. So for the time being, I am going to use the Eurocode 3 2005. I can select this one. The concrete design code, that is Eurocode 2 2004. If you wanted to use Indian standard, you can select this one. And if you wanted to use an American standard, you can select this one. So you can select the code, whatever you like. So now click OK. So now here the etabs is taking some time. Okay, here this is a new model cube template. Now this dialog box allows us to put the number of grids in x and y direction and the number of grids spacing in x and y direction, and the grid labels as well as the number of stories with their respective height. So here, as we said previously, the number of grid lines in x direction is 15, and the number of grid lines in y direction is 11. So we can count it again. Because we have to be sure. We just come to here. This is 1, 2. Just I'm counting the number of grids in x direction is 15, and the number of grids in y direction is 11. Now let me check in y direction, because in x direction I have already counted before. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, sorry. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 grids in y direction. And the spacing of grids in x direction, now I can take arbitrary dimension size, that is 4. And I can take also here 4. The grid label, that is here, the grid label should be consistent with the architectural design. Okay, we come to the architectural part here. Just I can show you one of the floor plan. Here in this here in y direction, that is the grid lines are designated with letter APC, and in y direction the grid lines are designated with the number 1 to 3. So here in x direction, that is A, the beginning in xit is A, and in y direction the beginning in yit is 1. But here the assignment will be given from left to right for in the case of x grid, and in the case of y grid the level will be provided from top to bottom, because number 1 starts at the top here, as you see. So from top to down, from top to down. Now here click OK. So when we come to also the story dimension, the number of story, as I said before, is 20, and typical story height I can take 3.2, and I can take 3.52, and this one is the bottom story height, that is 3.2, as I have said before. So later I will edit the story data as per the actual story heights which is specified in architectural design. So now click the grid only here. Now click OK. So now we need to edit the grids spacing as well as the designation of the grid lines as per the architectural design. So now here it is taking some time. It is scanning. So now here, as you see, just now let me here, the designation of the grid lines is PC in X direction, and the designation of the grid lines in Y direction is 1 to 3 from top to down. So now I have to edit the designations here and the spacing of the grid lines. So to do this, go to the edit menu and click edit stories and grid systems. So here I can edit the story first. So here this is the base or the basement 3. So this is also the basement 2, and this one is the basement 1, and here this is the first story, this is the second story, and this is the third story, and this is the fourth story, and this is the fifth story, and this is the seventh story. Sorry, this one is the ground, and here this one is the first floor, and this one is the second floor, and here this one is the third floor. Now the fourth floor. Here this one is the fifth floor, and this one is the sixth floor, and this one is the seventh floor, and this one is the eighth floor, and this one is the ninth floor, and this one is the ninth floor, and this one is the 10th floor, and this one is the 11th floor, and this one is the 12th floor, and this one is the 13th floor, and this one is the 14th floor, and this one is the 15th floor, and this one is the 16th floor, and this one is the 17th floor. Here we have 17th, the 17th story above the ground level and 3 stories below the ground level. So the height of here, as I have said before, the level of project and the level of stories can be taken from the sectional elevation drawing of the architectural parts here. When we see the basement stories, the third basement story is located at minus 9.6. So here the elevation is minus 9.6. So this grid, this cells having a gray color can be automatically, taken the elevation from the provided story height. So here 3.2. Now this one is also 3.2. Here this one is 3.2. But above the ground floor, right here, I think this one is 3.52. Here I can check it. It is 3.52. This one is 3.52. This one is 3.52. And here when we come to the last stories, the heights are different. Okay, just let me go to the higher story here. If this one is 2.8 and this one is 2.88. This one is 2.8 and here this one is 2.88. So here we can check the elevation here. The elevation of the last story is 58.48. So just we can 58.48, perfect. And here the mechanical rumps elevation is 55.68. That is 55.68. So this is perfect. And when we come to this, the ground floor is located at elevation of 0, and we can check it at the sectional elevation. But software drawing here, this one is 0, 0. So the ground floor is located at the level of 0. So this is okay. I'll click OK. When we come to the addition of the grid systems, here now I can select the display grid data as a spacing because it is easy to edit the grid ID and the X and Y spacing of the grid lines here. So now let me start at the grid lines drawn along the Y direction and X direction. Just to do this, now let me open the drawing, which indicates the level of the grid lines and their respective grid spacing. Okay, so here the first grid lines is drawn here. That is, the ID, the grid ID is A1. So now let me provide this A1. Here now the spacing is, it is here the spacing is 2375. I mean here the unit is in meter. 2375. When we come to the next grid, that is grid ID is A, which is consistent with the architectural part. So the spacing is 6.8. Here this is 6.8, and this one is A. So the third grid line is grid line B, which has a spacing of 2.602. 2602, but the grid ID is B. And when we came to also the fourth one, that is B1, and spacing is 6048. This is B1 and 1648. Now let me check it. It is 1648. 1648. So the third one is here. It is B2, spacing of 352. Here it is B2 and spacing of 0.352. 0.352. And the next grid is, it is grid line B3, spacing of 2.8. It is 2.8. And here this is the grid line B3. So, and the next grid lines is grid line B4, and spacing of 0.348, I think. Now let me 0.348. Here 0.348. And here this is the grid lines B4. And here the next one is grid line C, spacing of it is 1452. It is 1452. So this is grid line C. And the next grid line is grid line C1 with spacing of 6.293 and 8, 6298, 6298, 98. So this one is grid line C1. And here the next one is next to C1. Here I have grid line D, spacing of 2449, 2449, 2449, 49. That is grid line D. And next to grid line D, here we have a grid line E with spacing of 2046, 2046. And here is grid line E. And next to grid line E1 with spacing of 18005. Here 18005, and this is grid line E1. And next to grid line E1, here we have E2, spacing of here is 902. 902. This is E2. E2. So 0.902. Here E2, and next to E2, here I have E3. E3 having a grid spacing of this one 0.798, 0.798. That is E3. And next to E3, here I have E4 with a spacing of this is the last grid line. As it is the last grid line, it doesn't have any spacing, so we can take the spacing as 0. This one is 0, so that is E4. E4. Oh, this is all about the spacing in x direction. When we come to the spacing and the grid ID definition in y direction, here I have to start at grid ID 1. So now let me come to here. Now let me start at this grid line. So the grid ID is 1 and the spacing is 1.6. Here it is 1.6. Can take 1.6, and the second grid is 2 prime. It is 2 prime, and the spacing is it is 4921. Oh no, sorry. The spacing is where did I put the spacing? Okay, that is 2 prime here. Okay, sorry. Now let me zoom in. So here the dimensions are provided here. So 2 prime is 3321, is 3.3321, 3321, and the 30 grid lines is G1 prime, the spacing of 2779, 2779, 2779, 79, and this one is G1 prime, and the next grid is this grid line 2, having a spacing of 4.1. This is 4.1, 4.1, and this is the grid line 2. This is grid line 2, and next to grid line 2, here we have grid line 3, 3 prime, spacing of 1.6 is 1.6, and here it is 3 prime, 3 1 prime, and next to 3 1 prime, here we have a grid line 3, spacing of 2.1. This is 2.1. The grid line is 3, and when we come to the next grid line, that is for 2 prime with spacing of 2.8. That is for 2 prime, it is 2.8. So next to for 2 prime, here we have for 1 prime, spacing of 2.8. This is 2.8. This is for 1 prime. It is for 1 prime. So next to for 1 prime, I have this grid line 4, spacing of 7.3. Is 7.3. Then the grid ID is 4. And next to grid line 4, I have grid line 5 with a spacing of 4 point, I think it is 4.6. It's 4.6. And the grid ID is 5. And next to grid line 5, I have the last grid lines, which is grid line 6, spacing of 0, because I don't have any spacing next to grid line 6. Okay, this one is 6, and here this one is 0. So now click OK. Click OK. So here we can now, in order to see the level, because it is at 17th level, so as I have drawn the grid lines at basement 3, so I have to come back to the basement 3. Look here, this one is the designation of the grid lines, and here this one is also the designation of the grid lines. So I have to check the spacing of the grid lines with the architectural grid lines. Here I have to open it, the architectural design part. That is the architectural part here. So I have to take care that the grid spacing which is defined in architectural drawing must be consistent with the grid spacing which is taken into consideration during the modeling of the structure. So here I can take one of the floors. Now let me just open this one. Here I think it is not clear. Well, this one here, this is this 2.5, but here from the center of the grid lines to the center of, I mean from the center of the retaining wall to the center of the column, the dimension must be taken. Now let me show you here. I can draw this one. Okay, sorry. Draw line here, this one. Now I can dimension there from this here. Sorry, it is taking more time because my PC is busy. It is okay. Sorry, the snapping is not perfect. Sorry. Here I need to snap to the red color here. It is 2.350. So when we come to my grid spacing, it is 2.3, so 2.375. Sorry, now let me check it once again. Okay, now let me come back to the this drawing. I think it is better to show here. This one and this one. Here it is from the center of the retaining wall to the center of the column is 2375. Is perfect. And here when we calculate also the distance between A and B, it is 6.8. Here the distance between grid A and B, it is 6.8. It is perfect. The distance between grid B and C, it is 775. It is 775. That is now here to draw the dimension, just go to draw menu and click dimension line. Now here select this point. So here see this one is 7.75, which is good. The distance between B and C, here the distance between B and C, it is 7.75, and the distance between C and D, it is again 7.75, which is you can do. The distance between C and D. So go to the domain, here dimension line. Here this is the point. This one is the point. It is 7.75. It is perfect. And here the last one is this one is it is the distance between this grid lines and this grid lines is 2.449. So it is 2.449. It's perfect. Okay, now let me check the grid spacing along the y direction. So here to check it. Now the distance between the grid line 1 and the grid line 2. Here now let me come to the AutoCAD file here. The grid 1 to grid line 2, which is 7.7. So this dimension has to be kept here. So now draw the dimension line here. Now click this one, and now click this one here. It is 7.7. It is perfect. Now come to the next grid lines here. Now draw the dimension line here. The distance between the grid line 2 and the grid line 3, it is 5.7. So now let me check it on AutoCAD file here. So the distance between a grid line 2 and the grid line 3, it is 5.7. So the next grid spacing is here. Now linear dimension. Now this 3 and 4. It is 1. It is 7.7. Now we draw the dimension line here. It is between 3 and 4. That is 3 is this one and 4 is this one. So it is 7.7. It's perfect. And this one is 7.7. And the finals, it is not the final, but the grid spacing between 4 and 5, it is around 7.3. That is draw the dimension line here. That is 4 and 5. 4 and 5, it is 7.3. It is perfect. Here it is 7.3, and the final spacing is 4.6. That means the grid line between 5 and 6. Now draw the dimension line here and click this one and click this one. It is 4.6. So perfect. So here, this is, I think, all about the grid definition and the grid management of the 20-story building. And this is all about for this tutorial number 1. And the tutorial number 2, which is part 2, will be focusing on the definition of the material and the definition of the cross section of the column, the beam, the shear wall, the retaining wall, the slabs, and all the rest structural members. So for the timing, I think this is all about. Thank you for watching. Don't forget to subscribe my channel. So if you subscribe my channel, you will be getting a new updates of all related structural design tutorial. Thank you very much.